Okay, so the next topic that we have is nothing new to you. It is ionic equilibria. So we all know what equilibria is. Equilibria is a stage that happens when you have reversible reactions. And the dynamic equilibrium is always a stage in there. And understanding it tells us how you can control the rate of those reactions, how you can control the behavior of those reactions. So what's a reversible reaction? It's a reaction that happens in either direction, forward or backward. And what,
Sir,
yeah,
I'm so sorry, but are we done with entropy?
we are, yeah.
Oh, okay. ठीक है.
Why? Do you have
No,
any
I don't know.
questions?
We just had like one class. I was like in my
Yeah,
A
it's a
class.
really short topic. You
Yeah.
have Gibbs free energy, which tells you the spontaneity or feasibility of any reaction, and that's all that matters in this.
Also, sir, in energetics, past
Mhm,
papers में like vaporization वाले questions भी होते हैं. But in the
mhm.
syllabus, there is no mention of vaporization. So like, it's out of the syllabus now.
I'll have to look it up in the syllabus
Okay, ठीक है. Thank you.
because जो आपके practicals होते हैं ना, उनमें वो hydrated salt की बात करता है कि evaporation होनी चाहिए. लेकिन vaporization, you're right कि energetics में उसका especially उस term की कोई बात नहीं होती. But then again, vaporization is no different from other changes of state, right? There's nothing very special about it. And in energy, we know that how that energy is required to gain or lose. आपके syllabus में एक बात वो जरूर करता है, वो ये है कि the lattice energy when they define it, वो gaseous ion से solid lattice में जानी चाहिए. वो ये terms जरूर use करता है.
Got it.
Okay.
ठीक है.
Yeah.
Thank you.
Coming back to the equilibrium. So we need to be able to define what dynamic equilibrium is. We need to be able to define what reversible reactions are. And they're nothing new for us. We already know them. So now comes along the idea of ionic equilibrium. We've already done other kinds of equilibria. We've talked about pressure, we've talked about concentrations. Ions are something that we haven't really seen in a lot of detail. So before we get to how they do, let's talk about one particular reaction, which is, in fact, a particular kind of reaction, which is absolutely new or different from other reactions that we've done. So there are two broad categories of these kind of reactions. First one was redox. Redox reactions were all the reactions in which there was a transfer of electron involved. And when transfer of electrons is involved, sometimes ions are made, sometimes ions are reduced or oxidized, or वो वापस neutral हो जाते हैं. But the redox part is there. And then there is a huge number of reactions in which there's a transfer of proton. Have you seen those reactions? जिनमें electron नहीं transfer हो रहा, protons transfer हो रहे हैं. These reactions are called
Any reaction जिसमें H plus ions आते हैं, isn't that a proton?
exactly. Very good, Mohib. A proton is just a different name that we give to, or another way of looking at H plus ion. And these are called acid-base reactions. These make one of the 4 or 5 major categories of reactions in chemistry. And turns out you can easily define what acid and base is. So this is a whole class of compounds जो chemistry में हमारे पास है. So when scientists started learning about them, the first theory that came up was the Arrhenius theory. Again, you don't need to like remember the name, just know the idea that Arrhenius theory said, again, what's a theory? It's a way of explaining things. So उसने देखे reactions होते हुए तो उसने कहा इसके पीछे एक reason होगी. वो reason ये है कि acid gives H positive and alkali gives OH negative. So that's the idea that he gave. And the idea worked, except there were cases where things were still behaving like alkalis or giving us results that as alkalis would do, but without having any OH minus there. So then came along two, I think one of them was American, Brunstad and Laurie. And they gave us this idea that basically acid-base reaction is that acid gives or donates proton and base accepts protons. This is a much more broad explanation. And not just that, iska ek aur bada zabardast case hai. According to this explanation, water is both acid and base at the same time, which is kind of like weird. कि एक चीज acid भी है, base भी at the same time. But this one gives us a really straightforward answer to what acid is doing. Of course, ये गलत नहीं है, but this one gives a better explanation, a more all-encompassing explanation. And then came along this guy, who is one of my favorite chemists, Louis. And Louis' theory basically says that, wait a minute, don't think of this in terms of protons. Let's go back to the idea of electrons. Acid-base reactions are nothing but transfer or sharing of electron pairs. He said, देखो, 1, 2, 3 units of electrons transfer हो तो उसको redox बोल दो. Pairs transfer हो तो उसको acid-base बोल दो. And that also makes sense. And it doesn't have to transfer all the time. It could be sharing as well. And that is called dative bond, right? So now we have a completely different outline on things, a different way of looking at things. Acids accept lone pair and bases donate lone pair. And this one is a much, much broader explanation of why acid behave the way they do. And this is entirely consistent. So let me give you an example. We have acid. So let's say HCl le lete hain. I add HCl to water. What will happen? The Arrhenius theory basically said कि जब HCl को आप पानी में डालते हो ना, aqueous करते हो. So it basically breaks down into H positive and Cl negative. And NaOH, when you do that, when you add it to water, it breaks down into sodium ion and OH minus ion. And this H positive, because it is high, it is a lot of there. So इसकी वजह से वो acidic हो जाता है. और ये OH minus की वजह से वो alkaline हो जाता है. वो जो आपका aqueous solution है. And that makes sense. और mole levels में ये करते थे. But then wait a minute. Is this a chemical reaction or is this a physical change? What exactly is happening here? And why is HCl suddenly breaking down? Like water ने ऐसा क्या किया उसके साथ कि वो break down कर गया? Bronsted, Laurie and Louis' theories give us answers to that. वो कहते हैं कि देखो, ऐसा नहीं है कि आप HCl पानी में ऐड करते जाओगे और वो H positive और Cl minus बनाता जाएगा. जरूरी नहीं. There is going to be a case where it's saturated. Similarly, you're going to get weak acids like ethanoic acids, और वो भी break down करते हैं, but वो हमेशा weak, वो एक reversible reaction में कर रहे होते हैं. So there's all a reason behind that. And what is the role of water in all of this? Water ऐसा क्या ही कर रहा है कि हर एसिड जाके H positive देना शुरू कर देता है, हर एल्कली जाके वो H minus देना शुरू कर देती है. सॉल्ट्स क्यों नहीं करते ऐसे सारे के सारे? क्या है क्या वाटर में इतना स्पेशल? So this gives us a much better explanation of this. that देखें, water में oxygen है, उसमें lone pairs, and when HCl goes in there, that oxygen can give a lone pair to this H positive, जिसका last shell खाली है. And not just that, that's a Louis idea. Another way of looking at this is that water basically accepts one H positive in that process. Well, they are not contradictory. They're just two ways of looking at things. Oxygen अपना lone pair दे रहा है H positive को, या oxygen H positive को accept कर रहा है. Both of them are just different ways of looking at things. And this is how you're getting H3O positive and Cl minus ions. Now, there are two ways of looking at this. The one that we're used to looking at is, okay, HCl and water, when you mix them together, they give us this. State symbols are there. Obviously, HCl is a gas at room temperature and pressure. Water is a liquid, but the other two ions are there. And they're both aqueous. This one is called hydronium ion. Similarly, when NaOH is added to water, NaOH is a solid at room temperature. You can think about it like this. In fact, a better way of looking at what a base does is by looking at ammonia. So I'll come back to NaOH later, but let's look at ammonia. Because Arrhenius theory उसको explain नहीं कर सकती कि वो कैसे base है. But when you put ammonia in water, then what ammonia does is that water has H in a polar bond. So water वो H positive lose कर देता है. And it gives us ammonium and OH minus ion. Again, this is a gas, this is a liquid, this is an aqueous thing, this is an aqueous thing. And I will talk about NaOH later. But अभी के लिए हम इसको देखते हैं. This is one way of looking at things in the forward direction. Let's look at it in another way. What if I were to reverse this? What if I look at the backward reaction? क्योंकि मैं तो कह रहा हूँ कि ये reversible reaction है. What happens here? It's making water and HCl. And in this case, ammonium plus OH minus is making water plus ammonia. अब जरा देखते हैं. Let's try to label things. In the forward direction, what's happening? HCl has lost H positive. That means it is acid. And water has accepted H positive. So it is base. Let's look at the second case. In the forward side, H3O positive has lost one hydrogen and the positive charge. So clearly it is acid. And Cl minus has accepted an H positive. The negative charge है क्योंकि positive has cancelled it out. And it also has one H. So it's clearly, so we can say that this is again acid base. All that's happening in water is an acid and a base are reacting to make a different acid and a base. And the acids that they get from there, they're all related to each other. Because HCl has made base, an acid here is making a base there, and a base here is making an acid there. We call them conjugate pairs. Or you can also look at it like this. कि ये हमारे पास H2O and H3O positive are conjugate acids and base. And this one are conjugate acid and base. So these are conjugate pairs of things. Does the same thing apply here? Of course it does. Because if you notice, then ammonia has accepted H positive. So clearly it's a base, which means water is the one giving it that, and water has done that. It has lost H positive, OH negative रह गया उसके पास, so that's clearly an acid. And on the opposite side, that's also true. OH minus is going to accept one H positive. Now उसका negative ion रहेगा, now उसके पास एक hydrogen रहेगा. It's making water. So clearly this is a base and this is an acid. And this explains so much. All the behaviors of ammonia, समझ आ गए. They are no different from the behaviors of NaOH in terms of electrons or dative bonds happen. And then more than that, ये तो फिर H positive or OH negative है ना? There are cases where there are acid-base reactions. Why is carbon dioxide acidic? मतलब ना उसमें H है ना OH है. Why is ammonia a base reacting with boron trifluoride? Completely different compound, boron trifluoride. Ammonia उसके साथ react करना शुरू कर देता. क्यों? Because if you look at it, ammonia has a lone pair. Of course, its structure ऐसा नहीं होता है. It's trigonal pyramidal. But I'm just showing it out. So you have BF3, which is like अगर मैं इसकी Vesper के मुताबिक theory के मुताबिक बनाऊं तो ये ऐसा होता है. But what happens is that when they come close to each other or when they react, the BF3 is going to accept this lone pair. And there you go. Now they both have tetrahedral structure. What's happening here? Now H positive आया, no OH negative आया, and yet this is an acid-base reaction. Why? Because right now this is ammonia losing or sharing, losing नहीं होगा, sharing lone pair. Dative bond initiate कर रहा है और boron accept कर रहा है क्योंकि उसके पास एक orbital है जो खाली है. So that makes this an acid and this a base. And the age-old question of what is water? Let's look at it. Let's look at water. Water, if you take two molecules of water, they will do this. हो क्या रहा है? Over here, this one, it has an attraction. The hydrogen bond with the other one's hydrogen. तो वो अपना लोन पेयर हाइड्रोजन को दे देता है, making H3O positive. And when that happens, ये हाइड्रोजन जब इन दो इलेक्ट्रॉन्स के लालच में इधर आता है, it loses its own electron to OH. So water molecule is functioning, is working as both acid and base at the same time. हाँ, ये molecule अगर acid है तो ये molecule base है, and that is how they're happening. And this we call auto-ionization of water. Now here's the thing, for reasons that we don't need to get into at the moment, let's see, हमने equilibria को पढ़ा हुआ है, which side is the equilibria going to be in? Obviously, it depends on which side is stronger, which side is able to lose the H positive faster. So clearly, this reaction is more towards the left. And the best way to look at that would be to look at the concentration of these ions. Remember the Kc, Kp, and all of that we had? So let's try to see what happens. So let me just write the equilibrium constant for this. So I'm going to get H3O positive here, the concentration of that, times the OH negative concentration, divided by H2O's concentration, and there's two of them. But then through actual measurements, we see that this is a much, much larger value than these. ये बहुत ही कम है. So what do we do in that case? जब भी हमारे पास एक concentration है जो कि बहुत ही ज्यादा होती है compared to the other, इतनी ज्यादा होती है कि ये उसको फर्क ही नहीं डाल सकते. In fact, I can further simplify this equation to one water molecule ionizing to H positive and OH negative, because acid कोई फर्क तो नहीं पड़ रहा है. And इसका भी अगर मैं Kc देखूं तो वो H3O positive, H positive है अब, not H3O positive. Its concentration times OH minus concentration over water's concentration. And the water's concentration is insanely large. It's like dividing 1 by 10 million. 10 million के सामने 1 की कोई वैल्यू ही नहीं है. और अगर 10 million में से एक निकल भी आए तो 10 million is roughly still 10 million. 1 less than 10 million is what? 10 million. So we say कि because this reaction is so much towards the left, कि ये जो concentration है ना, इसको कोई फर्क नहीं पड़ने लगा. जिस चीज को फर्क ना पड़े, that is a constant. So this is a constant, and constants don't belong in here. We'll multiply all the constants to this side. Because this is the side that's changing, this is the side that's constant. They together make an equilibria constant. So हम सारे constants को एक side पे ले आते हैं. इसको हम इधर ले आएंगे, इसको इधर ले आएंगे. So what are we going to end up with? Remember, these two, they are the same thing, just in a different disguise. So this one, I'm bringing this water here. Why? Because water's concentration is a constant, and I'm bringing all the constants to the left side. So there you go. H2O's concentration times Kc gives me H positive plus OH negative concentration. And this thing, I'm going to give it a name. I'm going to call it Kw. Just to know that I'm water ki baat kar raha hu. Because all the constants are there. And this thing on the right, I'm going to call it the ions that I get from water multiplied, or in other words, ionic product of water. What's its unit? I have mole per dm cube times mole per dm cube. So I'm going to get mole squared dm minus 6. There you go. That's what I have. Okay. ठीक है. Equilibrium constant हमने लिख लिया. And clearly, the equilibrium is still towards the left. But how do you explain it? क्यों वो left की तरफ है? One explanation for that would be that ये reaction, this is winning over the other reaction because this is a much, much stronger acid-base pair. This is a far better acid than this, which is true. Because अगर आप इस reaction को देखो HCl वाले में, the equilibrium is mostly towards the right. क्यों? Because this acid is a far stronger acid than this one. तो usually हम क्या करते हैं कि जो weak वाली चीज होती है ना उसको conjugate बोल देते हैं. So in two acids in this reaction, if this is a stronger acid than this, हम इसको बोलेंगे acid और इसको बोलेंगे conjugate acid. Similarly, in these two bases, if this one is a stronger base and that is a weaker base, जिस तरह से भी है, we will call that a conjugate base pair. इस तरह से हो जाता है. तो अगर पहला हमने conjugate acid इसको बोल दिया ना, तो अब हम इसी को conjugate base बोलेंगे. Even if it is a stronger base, हम इस तरह से चलते हैं. That's just a convention that we have. Okay, so we have this. So they were like, okay, ठीक है, मान लिया. The concentration is very weak. What exactly is it? Like, कोई value तो होगी ना? So yep, that is true. There is a value. Turns out, at room temperature, remember, all equilibrium are affected by temperature. So it's important to specify the temperature. So at room temperature, which is 298 Kelvin, 1 out of 10 million water molecules form these ions. And this is an important idea. The 10 million is an important number. 1 out of 10 million. Can anybody tell me what is how many zeros are there in 10 million?
7.
7. Interesting. What is the pH of water at room temperature? It's the same
7.
thing. 7. So there was this guy, Sorensen. He was looking at these numbers. He saw कि जब मैं HCl की बात करता हूं ना, so if I add HCl to water, then the concentration of H positive in there compared to कि कितने water molecules के मुकाबले में कितने H positive आने. So it's like a ratio. H positive compared to water molecules. So he saw that if I add 0.1 mole per dm cube HCl, a strong acid, then the ratio comes out to be 1:10. And if I have 0.01 mole per dm cube HCl, still a strong acid, then the ratio of these comes out to be 1:100. Similarly, he kept on doing that. किसी और acid के साथ किया, तो let's suppose 0.00001 mole per dm cube जब था ना HCl, the concentration was 100,000. He was just looking at it. He was like, wait a minute. There is a way to look at these things. Why am I calling it 10, 100, 10, 100,000? Let me just call it 10 power 1, 10 power 2, 10 power 5. And then he saw that this number 1 is related to this because point के बाद पहला digit है ये. And this number 2 is related to this because point के बाद दूसरा digit है ये. And this number 5 is related to this क्योंकि point के बाद पांचवा digit है ये. And he was like, okay, ठीक है. Let me see. This is 1/10. That is 10 power minus 1. That is 0.1. Wait a minute. What? That is 0.1. This is 1/10 power 2, which is 10 power minus 2, which is this. This is 10 power minus 5, which is this. The concentration is telling me something. The concentration of hydrogen ion is somehow related to the concentration of the acid that I add, provided the acid completely ionizes. And not just that, the decimal place in which I get my first significant digit is same as the power that I have here. Power of H. And he came up with the idea of pH. Now, nobody knows for sure कि उसने power ही बोला था या P से उसका कुछ और मतलब था. He never elaborated on it. But there's a strong mathematical relation that you see here. Maths में ना, do you guys take maths? Well, there is a function in maths. You do? Is there a function? There is a function actually through which I can isolate the power. If I'm just interested in the power of the thing, then is there a word for it in maths? Power को कुछ और भी बोलते हैं. Power is also called log in math. जो चीज power पे apply होती है ना, वो चीज log पे apply होती है. Numbers multiply करें तो log powers add होती हैं, logs add होते हैं अगर numbers multiply करें. Numbers divide करें तो power minus होती है, numbers divide करें तो log भी minus ही होते हैं. So log is just another way of looking at it. Power के ऊपर वाली power हो तो multiply होती है, log के ऊपर power हो तो वो multiply होती है. Log is just a way of looking at power that mathematicians have. And then he was like, बहुत simple है. I'm going to call this thing the power of H positive in this concentration. And problem was कि वो negative में आ रही थी. क्यों? Water molecule is always going to be more than the H positive that you have added. So उसने कहा मैं उसको minus से multiply कर दूंगा to make it a positive number. And there he invented a very powerful idea of minus log of H positive. यानी इसकी power 1 है तो इसकी pH 1 है, इसकी power 2 है तो इस minus 2 है तो इसकी pH plus 2 है, इसकी power minus 5 है, इसकी pH plus 5 है, यानी इसकी concentration in the 5th digit जाके आ रही है, इसकी concentration in the 2nd digit जाके आ रही है. Now another important thing, pH 1 और pH 2 में आपस में कितना फर्क है? 10 times का. The ratio of H positive in a pH 1 thing is 10 times the ratio of H positive in pH 2. pH is a measure of concentration. This is not a measure of कि वो strong acid है या weak acid है. Strong और weak acid में सिर्फ एक idea है. Strong acid जितने H positive होते हैं सारे दे सकता है because the equilibrium is predominantly to this side in a strong acid, जैसे हमने यहाँ पे देखा. Because the equilibrium is so far to the right, हम 100% ions इधर निकल जाते हैं. In a weak acid, that doesn't happen. In a weak acid, the equilibrium keeps on fluctuating and usually वो इस तरफ को होता है. But out of the ones that actually do, they have the same pH as the same amount in a strong acid. So pH is not a measure of strong or weak acid. हाँ, usually हम उसको at same temperature compare कर ही लेते हैं. क्योंकि concentration same भी हो तो ionization same नहीं होती. But if they have the same ionization levels, then strong and weak acids will have the same pH. pH is a measure of concentration of hydrogen ion. And this is just telling me the first non-zero digit I get in the concentration of H positive ion. It's just another way of looking at powers of H positive. There? And this is also related to this ionic product of water. If you have H positive concentration more than the OH negative concentration, so उसको हमने नाम दे दिया acid. Going back to our original theory, just respecting Arrhenius, H positive ज़्यादा होगा अगर, तो इसका मतलब है वो acidic behavior ज़्यादा कर रहा. H positive कम होगा OH से, तो इसका मतलब है वो basic behavior ज़्यादा कर रहा. और अगर बराबर हो गए तो we say कि वो equally basic, equally acidic है, and that thing is what we call neutral. We will talk about how you can use this ionic product and the idea of pH in different questions. That's it for today.